Right, morning once again. Welcome to another session of client operating systems. And as far as today's session is concerned, we're looking at networking. I think you will discover that, excuse me, that the content that we'll look at as far as today's session is concerned will ultimately overlap from your network architecture module, because ultimately we're looking at just understanding Windows 10 network components, describing and literally configuring IPv4, also looking at the whole aspect of IPv6, then distinctively perform and monitor file sharing, just understanding exactly how to connect a Windows 10 machine to the net and so on. So it's all about just generic networking. The only distinctive difference now is that obviously the focus is more on the Windows 10 operating system as opposed to the generic configurations there. So obviously when you look at the basic overview that is associated with networking within your Windows 10 environments, the basic components that you'd want to look at in terms of what Windows 10 supports is your network and sharing center, your networks in general, and then your connections. So ultimately, your network and sharing center is just distinctively a central point in the Windows 10 configuration as far as management of your network, and also looking at what you're distinctively currently connected to. So within that setup, as far as your network and sharing center, you obviously be able to view your active networks and distinctively change your basic network settings as far as your environments would go. So ultimately, if you were to look at it from this perspective, let's see if we can quickly share the screen. So if you look at the whole concept of your network and sharing center, remember, you can search for that within your search bar as far as your Windows 10 install is concerned, or ultimately you can play around with the notification area as far as your computer system there is concerned. And obviously within that notification area, you've got your network connection. So it can either be Ethernet or Wi-Fi as far as basic connectivity there is concerned. And then ultimately, just by right-clicking on that specific icon, you can look at opening your network and internet settings. So if you click on that, ultimately your network settings should be displayed in this particular instance. So naturally, you've got your status, you've got Wi-Fi, you've got Ethernet, all the way down to proxy. And obviously, currently, as far as this particular machine is concerned, ultimately connected to Wi-Fi, you've got the actual status that is there. I think we've discussed this before when we were looking at the basic settings associated with your computing mechanisms. Obviously, within settings, your network and internet is part and parcel of that. So when you look at for instance, Wi-Fi connectivity that is there, you've got the general information as far as the actual connectivity, the name of your particular Wi-Fi connection, which is also known as double SID or SSID. Remember that particular acronym is short for Service Set Identifier. But ultimately, it's just the same thing as a network name within your wireless environments when you're discussing your computing mechanisms there. So ultimately, what you want to look at either when you're within the Wi-Fi environment or your Ethernet, literally you'll get your change adapter options, your change advanced sharing options. You'll obviously find the network and sharing center we were talking about a couple of seconds ago. And if you click on that, naturally you'll see what we were talking about earlier on in terms of just viewing your active network, which is the one that is there as far as the actual Wi-Fi connectivity there is concerned, and then obviously enable you to change basic network settings. So change your adapter settings, change advanced sharing options, obviously also looking at media streaming options associated with your basic installation in that regard. So ultimately, in early versions of your Windows, right, the operating system was simply aware of a network card being physically connected or not connected as far as the actual network is concerned. But then with Windows 10, it literally has been advanced to be network location aware. So literally, regardless of you being on a bounded platform or working with conducted media or wireless, the particular operating system has now been designed in such a way that it's literally supposed to automatically identify specific networks as far as your configuration there is concerned. So ultimately, what you want to familiarize yourself with is the network name, and literally look at also the location types. So literally each network location is distinctively assigned a location type. So when you first distinctively connect to a network, your Windows 10 would arguably prompt you if your computer system should be visible or discoverable to the other computer systems in the network. And then ultimately, depending on how you respond, different network settings are distinctively applied. So the location types that you get is a private network. You also look at a public network, and then you can also discover a domain network in that regard. So how to access this within your environments, you would click on your advanced sharing settings. Once you do that, then ultimately you should be able to find the actual network configurations that are there. So you've got a private network, you've got a guest or public, which is the current profile as far as this particular machine there is concerned. And then you can also even look at your domain network configurations as far as your particular setup there is concerned. So obviously within this particular environment, as far as your configurations there would go, your private network is distinctively used when your computer system is connected rather as part of a peer-to-peer network, right? I think we're already familiar with distinctive differences as far as your networking models they are concerned. You've got your peer-to-peer, you've got your client server. You can also even talk about the directory-based type of network configurations or models that are out there as far as your particular setups are concerned. So with your peer-to-peer, as you already know, you're looking at an environment where all machines within that particular environment are literally on the same level. If you want to look at it from a different perspective, you don't have a central or a machine that is responsible for user accounts, your particular users and groups as far as your configurations would go. Every particular machine would obviously sit with its own your own SAM database as far as login credentials they are concerned. So with peer-to-peer, all machines within that environment are typically one and the same. And this particular network is just looking at availing for the generic sharing of files and printers as far as your computing mechanisms that are concerned. And ultimately, computers on an actual private network can distinctively belong to a home group, right? But then when you look at a public network, on the other hand, your public network is obviously the default location type for any particular new network as far as your systems they are concerned, and is literally used when the computer is connected in an untrusted public location, obviously such as an airport, for instance, as far as your setups they are concerned. So these particular public locations, literally, you cannot be sure of who else is on the network. So you obviously have to have enhanced security features to try and avoid unauthorized access as far as your actual computer system is concerned, and obviously the network at large, if you want to look at it from a different point of view. So these connections are literally initiated from other computer systems on the public network are obviously distinctively blocked by default. So when it's private, like we were mentioning a couple of seconds ago, obviously all machines within that environment are, for lack of a better expression, familiar, right? But then the moment you go to, because you're dealing with a basic peer-to-peer network for sharing of those files we're talking about, as well as your basic devices like your print, or basic peripherals like your printers. But when in a public environment now, ultimately every particular machine is distinctively alien in that particular environment. So you obviously need to be very careful in the way in which you conduct as far as those public network environments they are concerned. Why? Because you are not certain what's happening as far as each individual computer system within that environment would go. So by default, any one of the connections that might be initiated by any machine within a public environment are automatically blocked by the system naturally for security reasons, right? And then obviously you've got a domain based network. And obviously this is the one that is normally used within corporate environments where your computer system is actually part of the domain. I think this is where the whole concept of your directory-based architectures come into play as far as basic configurations they are concerned. But obviously you'll discover that the basic computer settings for computer systems on a domain network are literally determined by a group policy as far as configurations would go. So remember, when you look at your local machine, when it comes to anything to do with security settings, you've got that local security policy platform or management console that we've looked at before, right? And what is happening with that particular setup, like we've mentioned in the previous session, is that it's responsible for the local machine. So any local security settings that you want to configure on your particular computer system on a client-side configuration, obviously is availed for by that local security policy. But the moment you move that same setup to a domain or within your directory-based architectures, then that security policy now literally upgrades to a group policy that is now determined by obviously the network administrator as far as your specific environments there would go. So that's part and parcel of what your distinctive location types as far as your particular networks they are concerned. So ultimately important for you to remember the private, public, and then naturally domain. And then also, when you're looking at the whole concept of network discovery, literally also access, like we mentioned earlier on, by accessing your advanced sharing settings as far as your particular setups they are concerned. And then ultimately, the options that you'll find. So if you expand, for instance, your private network there, you've got your network discovery, and then you also have your file and printer sharing mechanisms put in place there. So ultimately, what you're looking at when you're looking at the turn on network discovery option, literally you can distinctively see and access other machines and devices on the actual network itself. And obviously the other machines that are there can also see your computer system on the network and access any shared resources as far as your particular setup there is concerned. Obviously, the default configuration when the network is set to private, as you can see in this particular instance, and then you can obviously turn that off as far as your configuration would go, ultimately more applicable when you're running your public environment. So if you expand the public a section there, as you can see, by default, it's set to turn off, just to avoid, again, those security glitches that might arise as far as your basic setups would go. So when it comes to your connections, right, as another aspect that is relevant as far as your Windows 10 install is concerned, you've got your connections are literally composed of three distinctive platforms or sections, right? You've got your client and services, you've got your protocols, and then naturally you've got your network drivers, right? So literally when you look at client and services, these are just applications that use the network to distinctively communicate. So ultimately, if you want to look at it from a different point of view, a client allows you to connect to a particular service running on a remote computer system. So a client enables you to connect to a particular service running on a remote machine. And then on the other hand, a service literally allows you or allows your computer system to accept connections from obviously resources as far as your remote machine there is concerned. So your service literally allows your computer system to accept connections from and provide resources to your remote machine as far as basic setups would go. So typical examples of this would include, so I think if you go back as far as our particular network there, I think let's look at this particular connection. Once you click on whatever connection you've got there, either Wi-Fi or Ethernet, you want to access the properties section, right? As far as that particular window there is concerned, once you select properties, you'll have the particular configuration we're talking about with your networking and your sharing options distinctively displayed in that regard. So the clients we're talking about, as a typical example, would include your client for Microsoft Networks, which is the one that is currently highlighted as far as that particular dialog box is concerned, which literally allows Windows 10 to access shared files and printers on other network computers or other Windows computers, if you want to look at it from a different perspective. Then you will also have your a file and a sharing for Microsoft Networks. Again, this is to share files and printers with other Windows computers, as far as your particular setup there is concerned. Then you also have the quality of service packet scheduler, which is that one there. And with this, obviously, as far as setups there is concerned, this particular service just controls the flow of network traffic within your Windows 10 environment. So its main purpose is just controlling of the flow of network traffic as far as your Windows 10 environments there distinctively are concerned. So that's the client and services side. And then you've got the protocols, and then you've got your network drivers, right? So with your protocols, you've got two distinctive protocols that exist, right? You've got your IPv4 and your IPv6. I think from what you have already gone through as far as your network architecture module is concerned, your IPv4 is a 32-bit address, right? Because remember, when you're looking at it from computing environments, your computer system will obviously deal with binary, your combination of ones and zeros, and then obviously we deal with the decimal numbering system, right? So when you look at any particular IP address, just for argument's sake, you're looking at that particular IP within the decimal format, so or dotted notation, right? As a typical example, and obviously the computer system is using or is viewing that same number in its binary equivalent as far as configurations would go. So you've got a 32-bit IPv4 address, right? And then initially, this particular setup, when it comes to the net and so on, all the way back in the 80s, I think that 32-bit address total or range was literally enough at that particular point in time. But obviously, as technology grew, as connectivity grew, that total number of IP addresses that were associated with IPv4 literally became inadequate. That's the reason why IP version 6 was now designed to try and accommodate for the multitude of devices that are now connecting to the internet or the network, if you look at it from a different point of view. Right now, if you look at it from different perspectives, you could be an individual sitting with 3 gadgets that all require an IP address to connect to the net. So you've got your laptop, you've got your tablet, you've got your smartphone, and you're looking at your smart TV also connecting to the net. You're looking at your fridge also connecting to the net. You're looking at your alarm system also connecting to the internet. You're looking at your car as well, also connecting to the internet. So what that then means is that there's a need for the appropriate number of IP addresses to literally accommodate for that in that distinctive perspective. So I think if you want to look at it from a different point of view here, let's probably go and share this so that we can revisit. But again, like I said before, this is content that ultimately you're familiar with as far as your particular setup there is concerned. So what I was mentioning earlier on, you've got an IPv4 address, right, or version 4. As far as this particular address there is concerned, like we mentioned, this is a 32-bit address. So that particular IPv4 is a 32-bit add. So what we're saying is, if you were to put in 192.168.0.17 as a typical example, that's what a generic IPv4 looks like, right? And you've got 8 bits that are representing each distinctive portion as far as that particular IP address there is concerned. That's where the 32 bits comes from. But if you look at the total number of IP addresses within IPv4, remember, when you're looking at totality, you've got 32 bits, you're dealing with a binary configuration. So as far as decimal conversions they are concerned, you've got 2, which is your base 2, which is dealing with binary, and we've got 32 bits that equate to about 4.2 billion IP addresses as far as your particular setup there is concerned. I think the actual number, if you look at it, should be 4 294, if I'm not mistaken, and then I think someone can assist on this one. What is your 2 to the power 32? Should be 4.2 billion. What is your number there? Anyone? You can send your results in the chat section there. What is 2 to the power 32? Anyone? So 4.2 billion, I think it's 4,294,000,000 967 296. All right, so that's your total as far as your IP version 4 addresses they are concerned. So again, like I was mentioning, if you look at it back in the 80s, that number seemed massive, right? But obviously, if you're looking at it from the 2021 environment, right? Obviously, that doesn't make much sense for us in terms of a capacity, because you've got a multitude of devices that all connect to the net. And it's also important to realize that when you look at IPv4, you've got the classes, which is class A all the way to E. And as far as class A to E is concerned, we're not using the entirety of the classes there, or we're not literally using the entirety of the IP addresses in this particular instance. Why? Because you only have class A, B, and C, which is applicable as far as public configuration, access, and usage is concerned. Class D and E are reserved for research and experimentation, and the whole issue of multicasting and broadcasting as far as configurations would go. So ultimately, your class A to C is what is distinctively usable as far as your IP address configurations they are concerned. And then talk obviously to alleviate so this is about 4.2. So this is literally, like we said, about 4.2 billion IP addresses roughly. And then when you look at IP version 6 now, it looks at again, a basic accommodation of that number of IP addresses that is relevant. And some of the issues associated with integration is more or less highlighted with the fact that your IPv6 was not necessarily upgrading IPv4, but replacing IP version 4, right? So always when there's some kind of replacement of technology or architecture, there's going to be some discrepancies in terms of functionality at any particular point in time. So this IPv6 is 128-bit address now, right? And you can see that massive jump as far as your configuration would go. Obviously, as far as the actual total IP addresses there, again, 2 to the power 128, I think roughly this should be about 340 trillion IP addresses that are associated with this particular IPv6. So this, for the time being, I think it should be enough to literally accommodate for every particular device that needs some kind of connectivity to a network, some kind of connectivity to the net, if need be, as far as your configurations would go. But ultimately, remember, when you're looking at the whole concept of the net as well, you can even discuss the IP address, the private IP addresses or internal IP addressing schemes that literally try and enable better management of your IPv4 addresses, right? So in each one of those three classes that we mentioned a couple of moments ago, you've got a private address for class A, you've got another private address range for class B, you've got the same thing for class C. So that enables a bit of a better management scenario. Why? Because remember, internal addressing schemes, from what you are already familiar with, are non-routable. You cannot root an actual internal address. So this address that you find on the first slide there is a typical example of a private IP address or an internal IP address for class C, the 192.168.0.17. It's a non-routable IP, which means that I cannot connect to an external network using this particular IP. So you might then want to ask, how do you have internal IP addresses connect to the internet or connect to the external network? That's where your network address translation architecture comes in. to accommodate for that. But again, like I said before, this is material that you should literally be familiar with in that regard. So if we go back to that initial window that we had, as far as your particular configuration there is concerned, we can also see how you can configure these particular IPs as far as your particular setup there is concerned. Okay, so on, during chat, someone had sent through the number. Thanks a lot there as far as your contribution is concerned. So we're looking at, we go back to our settings here. As far as your configuration is concerned, let's see if we can actually get, where were we? So this is what we're actually looking at. All right, so as far as your particular IPs, you've got the IPv4. You can either double click on that option or click on it to highlight and then select properties. Obviously, it's selected by default because this particular address enables connectivity to some kind of network as far as your particular configurations there are concerned. So I'm going to select properties there, and this is where you would obviously select and incorporate your particular configuration as far as your IPs would go. So by default, within the Windows 10 environment or within your Windows environment, regardless of which version you're using, your DHCP service is an automated service. So every time you boot your machine, that DHCP service is typically running. And if you remember well, DHCP, short for Dynamic Host Configuration Protocol, its main purpose is to look at automatic assignment of IP addresses within any given network infrastructure. So when you look at, you can have your IP addresses statically or manually assigned, as well as automatically assigned. So normally when you look at a scenario where you're sitting with 50 machines, you're sitting with 100 machines, you're sitting with 200 machines and so on, that particular number is quite cumbersome if you're looking at having to manually move from one, or physically move from one particular machine to the other, and then manually incorporate the IP address. There's bound to be some kind of human error along the way, and ultimately it's not efficient, right? It takes quite a bit in terms of incorporating of these particular IP addresses as far as your machines would go. So if you look at the situation on campus, I think in Midrand you're looking at what, about 3 or 4 computer rooms. As far as these particular computer rooms are concerned, let's assume you're sitting with 30 machines as far as each particular room there is concerned. So if you're sitting with 4 particular computer rooms, you're already looking at 120 machines. So if you're having the IT office have to manually incorporate IP addresses across the board there, it takes time, it's not efficient, and ultimately you can get human error where you possibly plug in one particular IP for more than one machine, which means that those particular machines will obviously have problems connecting to the internet. So within your larger network environments, right, it's more appropriate for you to have a dedicated server, obviously within your environment that is got DHCP functionality that obviously automatically assigns any IP address to your network machines, right? And it's also important to note that right now, if you're sitting at home and you're connected through your Wi-Fi connection, you've got a router there and so on, that particular router also has DHCP functionality, right? So everyone that is sitting within your space there has got their smartphone connected, has got their tablet connected, has got their laptop connected, possibly you've got a desktop machine also connected, you've got your smart TV connected as a typical example. The router also acts as a DHCP server by automatically granting IP addresses to those particular gadgets. So you might be sitting with 5 gadgets there, but still there's that automated process associated with configuration. So when you want to manually assign these, so when it's automatic, it's good to go sit like that. We don't have any issues. We don't have to worry about much. But when you have to manually assign an IP, right, literally you need to select, use the following IP address. I think this is also applicable to your network architecture task 2 as well, where you'll obviously need to configure this accordingly as far as your particular servers, as well as your generic configuration in that particular task is concerned. Then you've got the IP address section, then you've got the subnet mask, default gateway, and then you also have a DNS server configuration. Now, DNS, normally when you look at configuration, your DNS server can literally work hand in hand with your DHCP, which means it's one particular server that runs that particular function. Your DNS, which is short for Domain Name Service, is an architecture that translates or converts an IP address into an FQDN, or a fully qualified domain name. So you've got an IP address of 10.0.17.56 as a typical example. That particular IP address can be translated into www something.com. Right, so your fully qualified domain name is the same thing as a website name, right, or a web address. Maybe if you look at it from a different point of view. So your DNS's main responsibility is just to convert an IP address into a fully qualified domain name for better management of the network. I think we can all testify that it's a lot easier for us to remember a web address or a website name as opposed to a string of numbers. How many websites do you access on a daily basis, right? So imagine you having to remember the actual IP addresses for these particular web addresses can be a bit cumbersome as far as accessing content there is concerned. So you got your IP address, you got your subnet mask, and I think, again, when you look at the whole concept of IPv4 setup, your subnet mask, any particular IP address, right, has got a network portion and has got a node portion or a host portion. So there's any particular IP address, whichever class you're using, whichever version also that you're using, you'll find that you've got a section that distinctively represents the network that particular gadget or device is in. And then you also have another portion that actually represents the host or the actual gadget in that particular instance. So that's what your subnet mask is responsible for, right? Identifying or assisting in identification of which is the network here and which is the actual computer system or node. So if you use that particular IP address that we had on one of the slides earlier, I think it's 168.0, I think it was 17, if I'm not mistaken. The moment you plug in that particular IP, right, you don't have to enter the subnet mask, because the system automatically identifies that, okay, this should be an IP address that is sitting within class C. As far as the IP version 4 classes are concerned, I've got A, B, and C with default subnet masks. So for class A, there's a default mask that enables you to identify network and node. There's a same difference applies for class B, same difference applies for class C. So the moment I click where it says subnet mask here, as you can see, automatically that mask is incorporated for me. But obviously, if you've got a custom mask that you're dealing with, you can obviously panel beat that accordingly. Obviously, the last portion there is what we can play around with in terms of changing or reconfiguring that subnet mask to accommodate our own network configuration and settings, right? And then obviously your default gateway there literally is the one that enables connectivity to the external network. So that is the IP address that is associated with your router, right? So your router, if you remember the OSI model, works at the third layer, which is your network layer. Its main responsibility is to avail for routing, right, or mapping a proper pathway from source to destination. So naturally, your router is also identified as a default gateway, because what does it do for you? Enables connectivity to an external network. So not just the internet, but connectivity to an external network as far as basic configurations they are concerned. So obviously, once you set that up, click on OK, and then you're good to go. You obviously will need to have the system test for you if that particular configuration works or not. If not, then obviously you might need to reconfigure as far as your particular setup is concerned, right? So that's how you'd access a section where you need to manually incorporate your IP address as far as your configurations there is concerned. So like I mentioned before, we are familiar with the classes as far as IPv4 there is concerned. I think it's imperative just to remember or to revisit the whole issue associated with configuration in this particular instance. So what it means is, I think let's go back to our slides here before we can start working with, or maybe before we even go there, let's look at running the let's go with our command prompt here. Let's run ipconfig for us to see exactly what's happening in this particular instance. Remember, ipconfig is short for Internet Protocol configuration, right? This is what you'd obviously use within a Windows environment. But should you be working with Linux, for instance, you've got your IF and your IW configurations that you can use in that environment. I think Mac is included there as well. But Ifconfig is the one that you'd obviously use when you're dealing with a Mac, with a Linux machine instead, as far as configurations would go. So you've got, remember, when you run command prompt, any particular command is used with a specific set of switches or options associated with it. So just assume that we're not familiar with what ipconfig does for us. You can hit the / and then obviously a question mark. If you hit enter, you'll have a whole host of options that are there, right? So if you look at your options there, what I've just done is look at displaying help in that environment. You've got all that shows you full configuration information. You've got your release, which releases your IPv4 address for the specific adapter, all the way to a set class ID for 6, which obviously works with your IPv6 as far as your DHCP configuration there is concerned. So we want to run with IP config / all, and obviously we want to concentrate on the current wireless connection that is there. So what you're looking at is by default, like we already saw in your GUI environment when we looked at the IPv4 settings there, you've got your DHCP enabled, which is currently set in that particular setup. And then you also have auto configuration naturally enabled in that regard. And then the IP version 4 address that we're looking at is 192.168.0.105, which is the current one associated with this machine. So naturally, this is an internal address, like I was talking about earlier on, or a private address, which means that this particular situation or this particular configuration utilizes NAT for that translation of internal IPs into a public IP address for connectivity to your external network. Then you obviously have the default gateway that is there, which is obviously the internal IP address of the router that is being used in this environment. And then that particular router that I was mentioning earlier on is also the DHCP server, right? It's the one that's also granting IP addresses within my home environment here. As far as configurations are concerned, it is also the DNS server. All right, so normally you find by default, the DNS and DHCP will normally work hand in hand as far as basic configuration in that particular instance there is concerned. So with your IPs, if you look at class A, for instance, remember class A starts from 1.0.0.0 all the way to 126, right? .255, 255, 255, as far as configurations would go. And the reason why your 127 is not included in that range, because remember the next class starts at 128, right? Which is class B. Then the reason why 127 is not included is because your 127 is distinctively reserved for troubleshooting purposes. So assume a typical example of that troubleshooting IP address that I can use is the 127.0.0.1 IP address, which literally links to every network interface card on the planet, right? That's the, you could say, virtual configuration that you've got, or connection that I've got. So assuming that I've plugged in my Ethernet cable, and for some odd reason, I'm still not getting connectivity, right? Before I physically inspect my network interface card or my NIC, I can literally run within the virtual environment, or within this particular environment, I can run a command to check if my network interface card is functioning without issue. And then if I get any discrepancies in terms of results in this particular instance, then ultimately I'll know that, okay, definitely my network interface card is malfunctioning and obviously needs replacing as far as configurations would go. So ultimately what you'd use is the ping command in this particular instance. Remember, ping is just checking for connectivity, and the IP address associated with your network interface card is also known as a loop back address, right? That's the one that you'd obviously look at checking as far as your network configuration would go. The moment I hit enter there, I should get replies, right? Which means that I should get a 0% loss and 100% connection. So the moment I get replies, I can, from a virtual point of view, maybe if you want to look at it from a different, or within this, the abstract point of view, this particular network interface card is functioning without issue, right? So it means that as far as functionality is concerned, everything should be good. If I'm having problems with connection, then possibly it's my it could be my cable, or it could be the actual connection or link to your central device, dependent on configurations in that particular instance. So the entirety of your 127 range is reserved for basic research and generic experimentation as far as your configurations there are concerned. So this is just, again, like I said before, just the whole concept of revisiting content that you're already familiar with. So normally you find that if we go back to, let's see if we can go back here. Right. So normally you'll find that when you look at the whole concept of your IPs, right? Just to make sure that we all are sorted in this particular instance. Remember, there are two particular IP addresses that you won't use as far as your configuration there is concerned, and that's all zeros and all ones, because your all zeros would be converted. If you convert it directly to your decimal, all zeros would be 0.0.0.0, and then all ones would be 255.255.255.255. So these particular IPs are not used because the first one does not literally assign to anything, but normally you find that in certain instances that IP is used for routing purposes as far as configuration would go. And then obviously the last IP address, besides the fact that it's in class E, right, which is not accessible as far as basic usage is concerned, it's also a typical example of a broadcast address. Remember, the last particular IP in your range is always going to be a broadcast address as far as configuration would go. And ultimately, like I mentioned before, it's also sitting within class E, class E, which is something that we can't distinctively use in that particular instance. So if you look at going back to that subnet mask scenario, we've mentioned that your subnet mask literally enables you to identify which part of the IP address is network ID, which part is host ID, right, as far as basic configurations are concerned. So to enable you to understand this, as far as your specific setups they are concerned, if you look at the private address ranges, right? So class A, B, and C has got its own private or internal addresses that can be used, right? Class A is 10.0.0.0 all the way to 10.255.255.255, right? And then B starts at 128. Sorry, my mistake. I'm looking at the entirety of the range now. 172.16.0.0 all the way to 172.31.255.255. And then your C starts at 192.168.0.0 all the way to 192.168.255. What's happening with our stylus here? 255. Right. So that's your particular, these are your private IP address ranges. So you get what is known as so in each one of these classes, you've got the default subnet mask. Remember, like I was mentioning earlier on. So you've got what they call a CIDR notation, or a classless interdomain routing notation. So you've got what they call a CIDR. So CIDR, which is also short for classless interdomain routing, right? So a typical example of what a CIDR notation would look like is 192 168.0. Let's assume that we've got our 17 again as far as configurations would go. And then in this particular instance, you'll get a / maybe 24. Right? That's a typical example of what a CIDR notation would distinctively look like. Right? And what this means is that the /24 represents the subnet mask. Right? So how does it represent the subnet mask? By identifying the network portion. How does it identify the network portion? By the number of ones in your subnet mask. So it means that in our particular subnet mask, we've got 24 ones as far as configurations would go. You can have that as 16, you can have that as 12, you can have 8 configured platforms. It all depends in terms of your generic configuration in that particular instance. So what it means is if we've got 24 ones in our subnet mask, right? It means that our 24 ones would be 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. That's 16. 1, 2, 3, 4, 5, 6, 7, 8. That's 24. 1, 2, 3, 4, 5, 6, 7, and 8. Remember, it's a 32-bit address. So this would directly translate to 255.255.255.0. So I'm not going to go into calculations there. I think you've already done that in network architecture there. So the /24 just represents the actual subnet mask. So whenever you look at an IP address or a notation written like this, this particular section is just identifying the network portion, or it's identifying the actual a network and as well as the host ID. So all you're looking at in terms of the /24 is the number of ones in your subnet mask, and obviously when you configure those accordingly, those number of ones would then translate directly to your configuration as far as your particular setup there is concerned. So ultimately, if you look at just by default, if you still work with that IP address configuration, when we're dealing with this, what it means is if we've got a CIDR notation of our IPv4 address, let's go to black here. So you've got 192.168.4.1, for instance, right? As far as this particular IP address is concerned, if you want to identify what the network portion and the node portion is all about, obviously, if it's your /24 configuration there, it means that our subnet mask is 255.255.255.0, right? What this means is that as far as the network portion is, so this represents the network portion. All the ones represent a network portion. So this here, this would be a network, right? And that literally would be host. So this is your network, and that would be your host, right? So all the ones represent network portions. All the zeros represent your host portions. So in this particular instance, same difference applies. That would be your network, and ultimately that particular part would be your distinctive host. So if you go and work with that particular IP on top there, it means that our network address is going to be 192.168.4.0, right? Because the first 3 numbers there, that will be your network address. So this will be net ID. And then when you look at the host, it's going to be obviously a 0.0.0.1, because the last part there is what is relevant in that particular instance. So this is going to be your host ID as far as your configuration would go. So ultimately, assuming that we've got 192.maybe 168.0.17 like we had initially, and we've got a /16 there. The 16 would obviously represent the number of ones, right? So we should be 8. So it means that, again, as far as our network portion configuration there is concerned, what it means in this particular instance that our subnet mask is going to be 255, which is 8 ones, plus another 8 ones to make 16, 255.0.0. Our network ID would then become 192.168.0.0. That's net ID, right? Because it's going to be the first 2 portions there. And then your host ID would obviously going to be a 0. Oopsie, let's go back to black. 0.0.0.17. Right, but ultimately, what you're actually looking at, as far as your configuration is concerned, is that the last two portions there would represent your host ID. Right. So, assuming that we had a just for argument's sake, to make it to make it more understandable, if we had a 3 there, just for argument's sake, then it obviously means that our host ID here becomes a 3 as well. All right. So that's your particular setup as far as the basic subnet mask configuration there is concerned. So ultimately important for you just to remember in terms of what the mask does and what you're looking at. So every time we look at a subnet mask that is 255, this is for class A, 255.0, it means our CIDR notation is /8, right? Because you got the 8 ones there. And then this is for class A, right? And then for class B, you've got 255.255.0.0. That's class B, that's /16. And then obviously because you got your 8 plus 8 there, and then you've got your 8 multiplied by 3, right? Because you've got 255.255.255.0. This is class C. That CIDR notation becomes /24 in that particular instance. So when it comes to your gateways, right? Like I mentioned before, any particular computer's default gateway is actually the router on the local network that is obviously used to distinctively deliver packets to remote networks as far as configurations would go. So in Windows 10, you find that the default gateway settings internally, Windows 10 rather, would store these default gateway settings internally as part and parcel of a much larger table that stores this information called the routing table. And in order for you to access this particular routing table, when you're dealing with your default gateways, you need to use the root print command. So if you go back to, if you were to go back to what we were looking at initially here, as far as our command line setup there is concerned, where's our command line here? There we go. So if you look at that command line setup, if you're looking at the whole concept of looking at the routing table associated with that default gateway that we were mentioning a couple of moments ago, you'd obviously need to use what is known as the root print command. Let's bring this up a bit. So that's root print. And then once you hit enter, it shows you that particular information associated with your generic routing table. So there's your root print command, and then it shows you the actual setup that you've got as far as your generic routing configuration there is concerned, as far as your configuration would go. So you've got an IPv4 routing table, right, as far as your configuration there is concerned. And then you'll also find there's an IPv6 routing table as far as your configuration would go. So that's the generics there. And I think we've already talked about what's happening with your DNS. Like we said before, if you got www.microsoft.com, you obviously have a distinctive IP address associated with that in terms of basic configuration. So ultimately, you can also use what they call the traceroute command. So let's assume we want to check and get the actual IP address of google.com, for instance. We can run the trace RT command. All right, and we can use / D there to check for it, and then we go www.google. Let's see if so. Let's bring this up a bit. Google.com there. We hit enter, and as you can see now, it is supposed to show us the actual IP address of google.com. Right, and as you can see, tracing route to www.google.com, you've got the 172.117.170.36. We can do the same for Microsoft.com. So Microsoft.com there. Hit enter. Oops, this is Microsift. I got a bit of a spelling issue here. Let's. I wonder what is incorporated as far as the Microsift web address is all about in that regard. So let's close this up quickly and let's see if we can run it accordingly. So let's look at canceling that. Let me see if I can quickly cancel that one and then go back and go to Microsoft instead of Microsoft. As far as configurations they're concerned, give me 2 seconds here while I quickly close this up. Right. Where were we here? Okay. There we go. So let's see if we can run that trace root command, right? And we're going to go www. Let's see if we can spell it correctly this time. Microsoft, right? .com. There you go. And then we hit enter. And then naturally it will give you what is happening as far as that particular setup there is concerned. So that's a typical configuration that you find as far as, so you can do that for literally any particular site, just so for you to understand the function of the DNS server. Like I said before, that DNS server's main responsibility is ultimately to look at converting your particular IP address to a fully qualified domain name, so that it's a lot easier for you to remember as far as basic configuration in that particular instance there is concerned. You will also discuss WINS, which is your Windows Internet Naming Service, but it's a bit of a legacy architecture really that literally resolved net bias names to IP address configurations as far as your setups there would go. And then ultimately, another thing that you also need to remember when you look at let's go back here. When you look at the whole issue associated with the assignment of IPs or configuring IPs. We talked about DHCP earlier, right? So we're already familiar with what's happening with DHCP. Again, you must have looked at that in your network architecture module, right? So manual assignment and also automatic assignment as far as configurations would go. If you've set your machine to automatically get its IP from the DHCP server. So in what we've seen in our previous examples there, if you set your computer system, obviously, to automatic, which is the one that's there by default, but for some odd reason, you can't connect to the net or you can't connect to the network. But when you run Ipconfig, you discover that you're sitting with an IP address that is within this particular range. So 169.254.0.0 all the way to 169.255.255.255. Oopsie, supposed to be 255 here. So .255. So what this means is that if you run Ipconfig and you find that your machine is now, as far as the preferred IP, your IP address is within this particular range. This range is literally known as your automatic private IP addressing, or a PIPA. So it's known as automatic private IP addressing, which is also known as a PIPA. It means that there's a problem with your DHCP server, or there's a problem with connectivity to the DHCP server, right? So and anytime you find that particular IP address, it's an automatic indication that there's a problem with your DHCP server, or there's a problem with connectivity from your machine to the actual DHCP server as far as basic configuration in that particular instance there is concerned. All right, so that's the basics there as far as IPv4 is concerned. I mean, it's ultimately the same kind of setup really with IP version 6, if you want to look at it from a different perspective. The only difference now is that instead of using decimal, because we're dealing with 128 bits, right? As far as your particular IP address configuration there is concerned, we still have the 8 distinctive portions, but obviously that means that we've got literally 16 bits per portion. So instead of dealing with decimal as we are dealing with now with IP version 4, that what you obviously find on screen, what you're now looking at with IP version 6 is hexadecimal to accommodate for those 16-bit configurations as far as your particular setup there is concerned. So one of the other things in terms of the utilities that you should familiarize yourself with as far as your IPv4 is the host name. So I think let's go back to our command prompt environment here for us to familiarize ourselves with this. Maybe let's write this down first in our notes. So when you're looking at the whole concept of the troubleshooting utility, so let's call these IP troubleshooting. This is within your Windows 10 environment as far as your command line is concerned. So troubleshooting utilities. Right, you're literally looking at, you can look at host name. You can also discuss the IP config that we looked at just now. You can also discuss the ping that we use also right now. Trace route, another thing that we used. So trace route. All right, and then let's see if we can add a couple more slides here. Hopefully we've got enough. 1, 2. All right, so I think hopefully that should be enough for us. And then you also can discuss path ping. So this is our 5th one, path ping. You can also even look at the root, netstat, in btstat. You can also look at getMAC. Obviously, that is for your MAC address configurations. ARP, which resolves MAC to IP and vice versa. When you talk about reverse ARP, so you got ARP there. You can also even talk about net shell. And then NS lookup. So this is the basic utilities within the IP configuration, within your command line environment rather, that you must literally familiarize yourself with. Obviously, with host name displays the host name of the computer that is currently running. We've already looked at IP config, already looked at ping, already looked at the trace route. Path ping, on the other hand, provides similar information to trace to the trace route or your trace RT configurations there, but obviously sends 100 ICMP requests per router in an attempt to obviously identify certain packet loss. Route displays and modifies information in your local routing table, your netstat, statistics of the information about network connections. In btstat, now dealing with net BIOS over your TCP/IP. getMAC, like we mentioned before, displays the actual physical address or your MAC address. ARP, that resolution of IP addresses to MAC addresses. And then you also have your net shell configurations there that enables modification of your particular network environment as far as configurations they are concerned. And then you've got your NS lookup. That's obviously for your DNS configuration. The NS is just short for the name service. Remember, we talked about DNS earlier. So if you want to look at some of these as far as your particular setups would go, ultimately, if you go back and share our so we go back to our command prompt environment there in this particular instance. Like I mentioned before, we already looked at the others, but just for you to see your host name, if you hit enter, it obviously displays the actual name of your machine mechanisms there. Obviously, with your trace route, right? Like we mentioned earlier on, if you're not familiar with the different commands or options associated with the trace route, it shows you the configuration that you've got as far as your particular setup is concerned. Remember, your trace route deals with your routers or movements of packets from router to router. And like we've mentioned, I think like you've already known, the movement of a packet from one particular router to another router is known as a hop. So you can look at the number of hops that are associated with getting to your distinctive destination. The less the hops, the better the connection. The more the hops that you've got, either the longer the route or the more problematic that particular connection is all about as far as configurations would go. So again, same difference with such commands as your getMac. As far as your particular machine mechanisms they are concerned, it will obviously show you the MAC addresses associated with your particular connection in that regard, as far as your particular setup there is concerned. And then obviously, like I mentioned before, if you're looking at the whole concept of your ARP again, you can always use that with a distinctive switch. And obviously, it will also even give you a short description of what it's responsible for as far as configurations would go. So obviously, with your IP config, you've got the all, release, renew, register DNS, and display DNS, flush DNS, which are the common commands that you're obviously supposed to familiarize yourself with, rather. So again, like I mentioned before, you've got your ipconfig / with a question mark for the help section. What you want to concentrate on is your all and release, right? Just understand exactly what's happening in that regard. And then you also want to look at your renew as far as your configuration would go, as far as that particular command is concerned. Then you also want to look at your register DNS as far as configurations are concerned, your display DNS as well, as far as your particular domain name service is concerned. And then you can also even look at your flash DNS configurations as far as your particular setups in that environment would go. With the ping command, with the one that tests for connectivity, again, if you were to type that out, you've got your distinctive switches that are there. So your ping T continues to ping indefinitely, right? Obviously, when you're looking at just checking for the appropriate connectivity and where packets are possibly lost as far as your environment there is concerned, you've got your A, which looks at resolving addresses to distinctive host names as far as your configuration would go. You've got your N, your 4, your 6, as far as basic configurations. Obviously, 4 and 6 are looking at IPv4 and IP version 6 in that particular environment. And then obviously with your root command, same difference applies. If you want to check how to distinctively use that, same difference would apply in this particular instance. You've got, again, where's our configuration here, a short description in terms of what's happening in that particular instance, and then also defining the whole concept of what is happening as far as your generic routing table configurations there is concerned. So obviously in your own, as far as your own machines they are concerned, also try and play around with these just for testing purposes, obviously, just to ensure that you're sorted in that particular instance. But then as far as IPv6, on the other hand, is concerned, so if you look at, let's see if we can go back to our actual windows here. We were looking at, so I think we can close that one. And then what were we looking at? This, all right. So if you want to look at the IPv6 setup that we were talking about earlier on, same environment, you've got your properties. And as far as these particular properties obviously are concerned, you've got the IPv4 configuration as well as IPv6 that is also activated there by default as far as your configurations there is concerned. So ultimately, if you want to access, this is what your IPv6 environment would look like, currently set as automatic. but alternatively, you can always use the following and enter configurations accordingly there as far as your particular setup there is concerned. Now, remember, like I mentioned earlier on, your IPv6 is a replacement of IPv4. So obviously, ultimately, you'll find that as far as IPv6 is concerned, ultimately addressed the shortcomings associated with your particular IPv4 as far as basic global networking there is concerned. So basic improvements that IPv6 brings with would incorporate obviously an increased addressing space at 128 bits. Remember, totals to that roughly 340 trillion IP addresses that you can use. Then you're also looking at some kind of hierarchical routing to obviously reduce the load as far as internet backbone configurations and routers are concerned. Simpler configuration through automatic address assignment. So whenever you have it within an automated environment, your IPv6 is simpler as far as configuration in that particular instance is concerned. Then you've got your quality of service also incorporated, inclusion of encryption services. So what this would then mean, remember, when you encrypt your data during transmission or before transmission, whichever way you want to look at it, it increases your security as far as configurations there are concerned. So obviously that's a plus as far as avoiding data being intercepted and obviously looking at unauthorized access as far as your network environments would go. And then obviously extensibility in terms of being able to support new features as far as your configurations there would go. So ultimately, a typical example of an actual IPv4 address would obviously use your distinctive hexadecimal assignment. So a typical address that you find as far as your IPv4 is concerned would be, now instead of using your dotted notation, you're now using a colon in terms of separation of settings that is there. So instead of using your dotted notation, you've got your colon incorporated there, and then you've got your configuration as far as your particular setup there is concerned. Remember, hexadecimal includes the numbers or the letters A to F as part of its numbering system as far as configurations would go. I think this is also something that you should be familiar with from computer architecture as well. So you've got that incorporated. So you've got 8 particular portions, right? And obviously all those 8 portions are represented by the 16 bits. That's the reason why hexadecimal becomes your default go-to in that particular instance. So you've got the other address or the other number or the other section as that. You've got the other section as 8234, for instance. The other one would be your quad zeros. And then lastly, or penultimately rather, you've got AC, and then you also have 099C. So this is a typical example of what your IPv4, v6 rather, address would literally look like. And remember, you've got a network and node portion as well in this particular setup. You want to look at it from a different point of view, but normally you've got the first 64-bit configurations associated with your environment, representing that subdivision as far as your configuration there is concerned. So ultimately, you'll find that when you're looking at the network portion, right, it's represented by the /64 as a typical example. So this network portion of the address is referred to in general as the address prefix, right? So the first 64 bits represent the actual network associated with your IPv6 addressing, and then obviously the last would obviously be associated with your node configuration in that particular instance. So instead of having the /24s and so on, typical examples of this would include your /64 as far as basic configurations there are concerned. So ultimately, that's the basics in that particular setup. And obviously, you'll find that when an IPv6 address contains literally a long set of zeros, right? The zeros can literally be compressed by a double colon, right? So your generic zeros can be more or less compressed into your double colon as far as configurations there is concerned. So ultimately, if you've got something along these lines, I think let's go back to our notes quickly. Right, so when it comes to IPv6, right? So when it comes to your IPv6 configuration, remember we mentioned that this is a 128-bit address configuration. So arguably, when you look at notations like we just saw in the previous setup that is there, if you've got a multicasting address, right, as far as connectivity would go, that would probably be represented by F02, and then you got your colon naturally, then you got your zeros, then you got your another set of zeros. So obviously the zeros that we're looking at there is your 4-0 configurations there. So you got your 0, you got another 0, got another 0, and then got another 0 in that particular instance, and then possibly the last section represented by that, oopsie, want to put this as an A, and then also represented by CC87. What you can do in terms of representation of this particular IP address is concerned is now this with the double colon that we're mentioning now. So let's see if we can actually incorporate those double colons so that they're actually visible in that particular instance. So you can now have this. Right, so that's how you can represent adjacent or obviously a string of zeros that is incorporated within your particular setup as far as configurations there would go. So with the prefixes, so in order for you to know specifically what a distinctive IP address is all about in that regard, as far as your configurations are concerned. So here, like I mentioned before, just for argument's sake, you can have the /64 configuration in that particular instance as far as your setup there is concerned. And obviously the first section, like we mentioned before, that 64 bits would literally represent the actual network associated with your setup. So it's important to understand what these prefixes are. So that those network prefixes are literally represented by that /64. So your common prefixes, as far as your environments would go, you've got what is known as the link local. And the common prefix associated with your link local configurations there is FE80. So every time you find FE80, you already know that this is distinctively a link local address. And then you also find global unicast. So we'll have a quick explanation on these in a moment. Unicast. You find that it starts with the 2000. And then obviously you got your colon and configurations incorporated there. You've got 3 there in that one. And then you've got your FC000. Oopsie, I'm actually representing the instead of the name. So we're looking at this one as a unique. This one is a unique local unicast. And this one is represented by your FC00 /7 there. And then you will also find there's another multicast. Remember, you should be familiar with broadcast, multicast, unicast in terms of the terms, as far as your network architecture also is concerned there. So if 00, and then you've got a double colon /8, and then you got any cast, which starts. So this is that now any particular unicast address. So your anycast is any valid unicast address as far as configurations are there concerned. So this one would be any valid unicast address. right? And then lastly, you've got Teredo. And this one is 2001, right? And then you've got a 32 configuration there. So when you look at your link local address, as far as configuration is concerned, this particular address, right? It's a unicast address that delivers a destination that identifies a specific single interface. So literally, when you're looking at it from a different perspective, a link local unicast address is automatically assigned to any active interface as far as your computer system there is concerned. So any active interface, as far as your particular machine would go, would obviously be identified as a distinctive link local address. So ultimately, I think you want to look at it from a different point of view. This is literally the direct opposite, or the IP version 6 version of your IPv4. So if you want to look at it from a different perspective. So if you go back to my let's go back to our Ipconfig here for you to actually understand exactly what we mean in this regard. So, for instance, if you go back to run Ipconfig, right? In this particular instance, Ipconfig, all here. If you go back to our configuration, you've got your IP version 4 preferred address, right? Which is that one. And as you can see, the link local IPv4 B6 address is the FE80 we're talking about. So this is just, if you want to look at it from a different point of view, it's just IPv4 version of IP version 6 as far as your particular configuration there is concerned. So it's an automatic IP address that is granted to any connected or active interface as far as your configuration would go. But alternatively, when you look at a global unicast, on the other hand, this particular address can be routed as a public address on the internet space as far as configurations would go. On the other hand, your unique local unicast address is a replacement address as far as your particular setup in that particular configuration will go. And obviously Teredo that we were looking at as the last type there is the same as your network address translation configuration, which obviously looks at converting internal addressing schemes to your external setups that is there. So what I'd want you to do, I think from a research point of view, look more at, so I think we can exit that. Let's go back to not sharing. Right, so what I'd want you to do, obviously, is as far as your basic research for your networking in this particular instance, as far as your Windows 10 is concerned, look more as far as IPv6 is concerned. So here we're going to discuss IPv6. So look at your an understanding in that particular aspect as far as your configurations would go. Also discuss file and folder sharing, right? And then you can also even discuss the whole concept of wireless networking. Right, I think that should be that's the reason why I was saying you find that most of this content is obviously going to work hand in hand with your network architecture configurations. I think the other thing that you'd also want to distinctively look at is just the Windows firewall. All right. Windows firewall, right, from a security point of view, and then that should be that as far as content there is concerned. So look through that as far as your configuration there is concerned, just to look at added understanding. And then you also have the review questions that are distinctively incorporated as far as page 313. So here we can just say for review 313 to this will obviously also help you understand content a little bit better, and 317. So these are the distinctive review questions. So that's your basic in terms of particular setup there is concerned. So ultimately, I think I've unmuted mics there. Feel free to ask questions, state your concerns or your contributions, or even use chat if you are comfortable with that environment as opposed to your mic setups there. So I think your mics should be up and running. Right, do we have any questions, contributions, or concerns from anyone as far as this particular session is concerned? Questions, contributions, concerns? Any questions, any contributions, and or concerns from anyone? Right, I think we're good. Nothing is coming through, so I'm assuming that we're all sorted in that regard. A little later on, I'll upload this recording on the YouTube channel. Have a quick look at it, and then should you need any clarity after going through that content again, or obviously going through the review questions or the research questions that I mentioned, pop me a mail, and then we can always engage ourselves accordingly in that on that particular platform. Otherwise, stay safe, keep smiling, be of good spirits. We'll see you in the next one. Cheers.